Welcome to my series of videos on the basics of computer science. Now, in this series of videos, I plan on showing you some of the basics of computer science and to get you off your feet in coding. Now, I'm going to be coding a lot in C++. It's a pretty powerful and robust language, but it's not the only one, and a lot of people like many other languages such as Java or Basic or Pascal or something like that for learning. Keep in mind, a lot of the things I'm going to teach you are not language specific, so a lot of the basic structures will be the same from language to language, and even some of the syntax, or a lot of the syntax will be the same from language to language. So it's not going to really matter that I'm doing it in C++, with the exception of a few things that will be different for Java or Pascal or whatever other language you're using. But overall, the structure of the language is the same. Okay, I'm also going to assume in my videos that you already know how to use the user interface. So I'm not going to show you how to create new projects or how to organize your folders or something like that. I may do that in another video, but in these videos I'm going to be focusing specifically on just coding itself. Right? So let's get started. In this video I want to first talk about just showing you around a basic code. Okay, and then I want to talk about basic variable types and the naming conventions for variables, basic input and output commands, and basic mathematical and logical operators. Okay, so a basic computer program in C++ looks just like this. Okay, now what we have here is the main program. Okay, and the main program, these are called, I just call them scope brackets, but they probably have like a computer science name. Basically what these mean is that the main program starts here and ends here. Okay, so if you write some code over here or up here, you're not including it as part of the main program. Okay, a return zero, I'll explain later what this means when we're talking about methods and functions. However, just for now, you can assume that return zero means end the program. Okay. These two lines together essentially are what's called a preprocessor definition. Okay, so a preprocessor definition is basically the importing of additional functionality into the language. So what it means is that when we're working in C++ or Java or something like that, they don't include every possible command in the language. Okay, because sometimes you're not going to need all those commands. So for instance, it's not going to include the commands for internet protocols, or it's not going to include the commands for graphics rendering if it doesn't need them. So what we do is that we just include these preprocessor definitions to include what are called libraries of other commands as we need them. So right now I'm including this library called IOStream. Okay, and what IOStream is, it's a library that houses the inputting and outputting commands, and that's going to be pretty important for what I'm doing today. Most compilers, or most programming suites will already include this one for you. Okay, now using namespace standards is a little bit more complicated, but for now, let's just say that we have to have it in order to make IOStream work, and I'll explain how it works later on, or why it's necessary later on. Okay, you'll see that the computer is actually really cool in that it names and it colors different parts of the program, different colors depending on what they are. Okay, so blue items are C++ keywords. Okay, green items are the preprocessor definitions, and these gray items are comments. Okay, so what I've done here is I've put in this outline of what I'm going to talk about in comments. Okay, and you do that by putting a /* and then commenting whatever you want, and then following it with a */. Okay, so if I move this down here, you'll see the rest turns gray because those turn into comments as well. Now comments are really important in your code. Now what they allow you to do is remember what you were doing before, but they also allow you to collaborate with other people and let other people both alter and maintain your code. So it's really important to try and to include comments in your code. Alright, now when the computer converts this into a computer program, it's going to ignore this comment. It will ignore all the comments. So you can put whatever you really want in there, and they can be as lengthy as you want, but for the most part they should be informative. Okay, so that's the basics of showing you around a computer program, and I'm going to go off screen and compile this here. Okay, so when I compile it, I'm just building what's called a console application. Okay, so my antivirus thinks that this is a Trojan horse, but it's not. Okay, so basically what it means is it's going to pull up the program in a console, and since this program doesn't do anything, it says that the program didn't do anything. Okay, so what I'm going to show you then, that's showing you around the code. Okay, it's the very basics of computer code. Okay, so next thing to talk about is variable types and naming conventions. Now, for variable types, what we're doing is in programming is we're typically modeling a situation mathematically, and so what we need is to use variables to either represent values or to hold other values. Okay, so it's the computer's way of holding information in its brain. So that's a way of thinking about it. Okay, now there's different types of variables, and you got to think of a variable as like a container. Okay, so it's a container that can hold a certain type of thing. So it's a very specialized type of container. Okay, so what we have is the first one is the simplest type of thing, which you might consider to be an integer. Okay, now an int or integer is a whole number, either positive or negative, and including 0. Okay, now associated with ints are shorts and also longs. Okay, now all of these are positive or negative whole number values. Okay, however, a short takes up half the size in memory that an int does, and a long takes up twice as much. And the reason why they do this is because basically, in a nutshell, a short has fewer place values to hold the number, and a long has more place values than an int to hold a number. And what that means is that although a long takes twice as much memory as an int, it can hold basically a much larger number in it. Okay? If you don't really get that, what you should do is perhaps look at my video on number-based conversions, and you'll see how computers store numbers, and by having more place values, you can have more or larger numbers. Okay, so you have ints, shorts, and longs. Okay, now typically though, you're going to just use integers. Okay, I don't really know a lot of people that have just programmed with just shorts and longs or anything, and for the most part, most people just use integers. Okay, secondly, there is something called float and double. Now, floats and doubles are stored differently than integers. Okay, but essentially what you need to know at this point is that a float and a double is a decimal number. Okay, a floating point number is half the size of a double, so a double uses a lot more memory comparatively, but it also has a lot greater precision. In general, we usually use doubles over floats because of this precision. Okay. Okay, we have something called a char. And a char is basically a single character. Now, a character can be like a letter P, or it could be a number 9. Okay, but one thing you have to remember, or you should know, is that the number 9 is different from the character 9. Okay, so the computer, when it's talking about integer 9, it's talking about the actual mathematical value of 9, and it can do operations on it. When it's talking about the character 9, it's just talking about the symbol that looks like the number 9. Okay, then it's a symbol that you would associate to the value of 9, but it can't actually do the same mathematics with it as you might expect. Okay, so but chars also include punctuation and basically anything you can type into your keyboard. Okay, so another one is a bool. Okay, now a Boolean value is essentially a value that can either be true or false. Okay, it can only have a true or false value, and typically these are used to indicate the state of some sort of condition that's running in a program. That's probably a little bit confusing right now, but just bear with me. Okay. Finally, we have something called a string. Now, a string is not really part of the C++ language. It is also not something called a primitive. Now, all of these different types are referred to as being primitives, and they're referred to being primitives because they are basically the simplest form of data that you can hold. Okay, now a string is not a primitive because it is made up of other chars. So a string essentially is made up of other things, so it's not considered to be the most fundamental typesetting. Okay, so when we're writing programs, what we do is, for instance, we might declare an integer. Okay, so I might say int number 1. Okay, now this means that I have created a variable to store a value. The name of the variable is number 1, and the type of thing that it holds is an integer. Okay. Now when I create this, I can also give it an initial value. So let's say I give it an initial value of 10. Okay, so right away I put a value in that. Now also one thing I should mention, and there's a lot of little things that need to be mentioned as you go along, but most people will get it in time, is that every command ends, whenever a command ends in programming, typically almost every language, it has to end with a semicolon. Okay, so anyways, that's why we have semicolons here and here and here. Okay, getting back to variables. So I've declared this integer called number 1. And now's a good time to talk about naming conventions. Now, although you can name a variable typically anything you want, there are some limitations. Okay, the first one is that you cannot name it after a C++ keyword. Okay, so you can't call it return or continue or something like that, because otherwise the computer would have no way of knowing if you're talking about the code word or if you're talking about the variable word. Okay, so no programming keywords. Another thing is that it cannot start with a number, and it cannot have any punctuation in it except for an underscore. Okay, so it can have numbers in it, but it can't start with one. So 9 number would not be okay, but number 9 would be just fine. Okay. Similarly, it could start with an underscore like this, like wish or something like that. Okay, but it cannot have any other punctuation, so something like, like that is not allowed. All right. There's two other conventions. One is that when we want to name variables, especially with multiple names in them, so if I want to say like first choice, for instance, there's a couple different ways you could say that. Now, one way is to do it like this. Okay, so first choice. This is generally not really preferred. Okay, but the standard convention right now is to use this camel case method, or sometimes referred to as the camel's hump method. And basically what it means is that we start off all of our variables with lowercase letters, and every new word starts with an uppercase letter, and we just don't put spaces in between them. Okay, because putting spaces is not also another thing that's not allowed. Some other programmers prefer to write it like this, okay, with an underscore separating words. That's technically okay too, but programming variables with an underscore becomes kind of unwieldy and cumbersome, and most people don't really like to do it this way. Okay, so the other thing is that you should name your variable in a meaningful way. Right? So if your variable is a choice, let's say it's the first choice, you might want to call it choice 1. Okay? Don't call it just like P. Right? Now, the reason why is because later on in your writing programs, you're going to get a lot of programs that could have a lot of variables. And if you just name them with like single letters or like a letter number combination like P7 or something like that, it's going to be impossible to remember what that does. And then you're going to have a hard time later modifying programs. Okay, so try and avoid just giving single letter variable names, and you should try and put a meaningful label onto the variable. Okay, the next thing that we're going to do is basic input and output. Okay, so I'm going to set this number just to be equal to 10, and this is just an arbitrary number that I'm just pulling out of my head here. It could be anything. Okay, now the first one is a command called cout, and basically what this is telling the computer to output something onto the screen. Okay, so cout has to be followed with these pointy arrow operators. Okay, now basically what I like to do is think of them as like a little mouth that's talking, so cout is talking out, right? And then basically you put whatever you want to be outputted to the screen after these arrow operators. So I might write something like the number is, okay, now I put these in quotations because all strings in C++ have to be listed in quotations. Okay, so the number is, and then I'm going to separate it with another one here, another set of pointy brackets, and I'll just say number. Okay, there's a couple of different things going on here. A lot of people ask, like, well, why did you have to separate it with these arrows? And essentially what it is that C++ needs to know that this is a different thing from this. Okay, so this is a string and this is a variable, and a computer has to be able to tell that they are different. So you can show it that it's different by separating it with this. Okay. All right. So let's just take a look what this looks like. Okay, so I run the code. Okay, and it says the number is 10. Now it kind of looks really ugly here because it's not really formatted very well. So what I'm going to do is I'm going to say the number is, and just put a colon there or a space. Okay, and I'm also going to add something else here. Okay, and it's a command called endline, or ENDL. Okay, an endline drops the cursor to the next line. So before we had information appearing right after the number 10, okay, on the same line, and so now that information will be dropped down to the next line when we run the program again. Okay, so we run the program again, and so now you can see it's been dropped down to a new line, and everything's a little bit nicer looking. And that's what I would expect from anyone who's programming for me, and I'm sure other people would expect it from you. It's just to make it look nice as well. Okay. Anyways, that's the essential part of outputting. Okay, now inputting, however, is a little bit different. Okay, so what I'm going to do is I'm going to include a user-friendly prompt. Okay, now a prompt is basically when the computer program asks you for input. So I might say, please enter a number. Okay, for now, we can just assume that the user is going to actually enter a number and not some junk input that we have to handle later. And I'll teach you how to do that later on. Okay, but so they say, please enter a number, and let's get rid of the 10 here. So right now we have the number, it just says please enter a number, and we're going to wait for the user to enter a number and then echo it back. Okay, so the command for entering a number is called cin, and it has its arrow operators in the opposite direction. Okay, and then what you include after the cin is the variable that you want the data from the keyboard to be stored in. Okay, now let's just see here. There we go. So what I'm going to do is I'm going to just run this again and show you how it works. Okay, so now it says please enter a number, and that's from this prompt here. And the reason why the computer is just hanging is because it's waiting for me to actually enter a number into the keyboard. Okay, so if I enter like 58, okay, then the computer echoes that back and says that I entered 58. Okay, and that's essentially it. Okay, for input and output. Now a common thing that a lot of young programmers make is that they mix up the cin and cout, and so they'll say like cout the number is, and then they try and flip the arrows and include the variable as if you could do it all in one line. Okay, so just remember that you can't do it in one line, it has to be done separately. And it's a good way to think of your programs as just like, you know, that they are all just a collection of separate commands. Okay? Okay, so that's cout and cin. Alright, now lastly is the basic mathematical and logical operators. Okay, now basic mathematical operators are going to be plus, minus, divide, and times. Okay, and another one called modulus. Okay, it might be a little bit hard to see there, but the modulus is shown with a percentage sign. Okay, and what the modulus is a common thing that most people know about, but no one ever really uses. It's actually something called the remainder. Right, so I'll show you through an example here. Okay, so let's say for instance I did something like 17 divided by 5, and let's go back to our days of log division. Okay, so I'm going to try and straighten this out. 5 divided by, or 17 divided by 5. Okay, now in the way we typically do this is we say, okay, well 5 goes into 17 3 times, and then you multiply it back and you have 15, and you subtract them and you say 2. And then what we typically do is we put like a 0 here and we carry it down, and then we'd say, well this is a 20, and so this would be 3.5. 4. Okay, but there was a time probably when you didn't do that. You said, well, the result of this is 2, and you said that you'd have a remainder of 2. Okay, now what this means is that 17 divided by 5 is equal to 3. Okay, so this number. Okay, 17 modulus 5 is equal to 2. Okay, so this number. And although it seems kind of silly, this is actually a really, really powerful operator. Okay, and most people don't use it in their everyday lives, but it's actually really, really important for computer science. So I really encourage you to make sure you understand how the modulus works. Okay, so then what we have here is so add, subtract, divide, multiply, modulus. Those are essentially your basic basic operators. Now there's some other ones as well. Okay, there's one called plus plus and one called minus minus. And what those do is plus plus adds a number to the variable, minus minus subtracts a number from the variable. Okay, so for instance, if I said enter a number and then I said number plus plus, okay, then that number would suddenly get 1 added to it, and I'll show you how that works. Okay. And, oh, yeah, I didn't like my extra codes here. Okay, so it's waiting for the number, and I'll enter the number 10. Okay, but it repeated and said that the number is 11. And the reason why I did that is because I have the number plus plus that adds 1 to the number that I entered. Okay, there is a difference between number plus plus and plus plus number, but I'm going to go through that in a different video. Okay, and there's also, as I said, there's minus minus, which would do the same thing except for subtraction. You can only ever add 1 or subtract 1 in this fashion, so you can't say like plus 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 to add like 4 or something like that. It's just plus plus, that's it. Okay. Those are the basic mathematical operators, and there are some other ones called logical operators, and I want to talk about quickly as well. Okay, now a logical operator is usually one used for comparison. Okay, so they are greater than, less than, greater than or equal to, less than or equal to. There is one called not, okay, and not equal to, and another one finally called equal to. Now, the equal to in this case is a double equal sign, and the reason why is because it's not meant to be an assignment. Okay, so for instance, when I say in my code that number equals 10, okay, versus number equals 10, okay, I'm actually doing two completely different things. In this first line, what I am doing is I am setting the value of number to be equal to 10. Okay, in the second one, what I'm doing is I'm asking the computer, does number equal to 10? Okay, so they are not the same thing. Okay, this one is for assignment, this one is for comparison. Okay, and I will write those down. That's for assignment. Okay, and that's for comparison. Okay, and you just see here, yeah, essentially that's it. Okay, now it's a lot to digest all at once, but for the most part these are really some of the basics of computer science. Later on I'm going to show you how to apply these and use them into some core algorithms, and then I'll show you how to do some neater stuff with computers. So anyways, I hope this helps. If you have any questions, then drop a line in the comment box or send me an email. If you like the video, then please give it a thumbs up, and if you like my channel, then please subscribe.